Hi everyone, thank you so much for coming. What the fuck is cloud native? Today we are going to talk about what we've learned from reading 100 Kubernetes Post-Mortem. My name is Noaa Barki. I'm super excited to be here. I'm a full stack developer. I'm based here in Israel, Tel Aviv, and I'm also a tech writer and one of the leaders of GitHub Israel community, which is the largest GitHub community in the whole universe. And also I work at an amazing company called The Tree, where we help developers to prevent Kubernetes misconfigurations from ever reaching production. And the reason that I'm telling you that is because partly my job as a developer in The Tree is not only to understand about Kubernetes, how it works, and to read 100 plus Kubernetes postmortems, but it's also to understand how you can blow up your own cluster. So just for today, I picked the top Kubernetes failure stories in my opinion, and I would like to welcome you to my very own private show, What the Fuck's the Mistake game show. So what we're going to do is that I'll show you a resource, and I'll wait for like 2 seconds, and you will have to guess or say to yourself, what's the mistake in that resource? Then I'll show you the correct answer, and we'll talk about the event. Are you ready? I hope you're ready because I am. Let's get it started. This is the cron job configuration, the default cron job configuration. What's the mistake here? And the correct answer would be the concurrency policy. We always want to make sure that we set the concurrency policy to either forbid or to replace. The reason for that is that when we set it to allow, whenever the cron job would get failed, the next job will not replace the previous one. And this is actually what happened to Target. They had one failing cron job that created thousands pods that were constantly restarting. And not only that it took their cluster down immediately, it also cost them a lot of money. Target taught me how important it is to never ever trust the default configuration. But let's move forward to the next question. This is another cron job configuration. What's the mistake here? And the correct answer would be incorrect YAML structure. As you can see, they did use the forbid in the concurrency policy. However, they placed it incorrectly in their YAML structure. Instead of placing it here, they placed it here. So the concurrency policy wasn't part of the cron job spec. This is actually what happened to Zalando. And they ended up with a cron job without any limits, so their API server was down due to out-of-memory issues. Zalando taught me the importance of having a clearly defined policies and validation standards in your organization. Let's move forward to the next question. This is an ingress resource. What's the mistake here? And the correct answer would be the host. We want to make sure that we prevent user from specifying host as a star. You might want to use star in your ingress resource, but just know that when you put a star in your ingress resource, Kubernetes will forward all that traffic to that container, and you might end up with one container taking up all the traffic from an entire cluster, and that might be problematic. And this is actually what happened to Target. It was their first incident in Kubernetes, and one of the developers set a star as a host in the ingress resource, which immediately took their entire cluster down. And the lesson that I've learned from Target is how important it is to delegate the DevOps knowledge inside the organization to the developers teams. But let's move forward to the next question. This is maybe not an innocent pod. What's the mistake here? And the correct answer would be no limits. We want to make sure that we specify the requests and limits, especially for third-party applications. This time it's about Blue Matador. They had one pod that served a third-party application whose containers were memory hogs, but without any limits, which means that Kubernetes didn't stop those pods from taking up all the memory in the node, which immediately took their entire cluster down due to out-of-memory issues. Now, Blue Matador, as a small startup company, they taught me the most important lesson of all. that it can really happen to anyone. There is no company that is immune to misconfigurations, especially in Kubernetes. But to sum up, my main takeaways from all the 100 plus Kubernetes postmortems is to never trust the default configuration, to define the policies in your organization, delegate the knowledge, and just remember above all that it can really happen to anyone. And when I say anyone, I mean anyone. Google, Spotify, Airbnb, Skyscanner, Datadog, they all had a misconfiguration with Kubernetes. And misconfiguration is something that all the companies want to and desire to prevent. And that's led me to the main question: how you can prevent it in the future, how you can make sure that you won't become one of those failure stories. And I asked myself that very own question. So I summed it up into 3 main steps that you can use in order to protect your cluster. So step number 1 is to define your policies. At the end of the day, the policies in your organization should be whatever it takes to make you feel confident with your code changes, whatever it takes to make you feel confident so you can ship your code to production. As a developer, I run unit testing, integration testing, bunch of testing, and I follow code conventions and clean code. This is what I need to do in order to feel confident with my code. So I really want you to think about what are the rules in your organization. What do you want to enforce? Whether it will be a valid YAML structure, whether it would be to make sure that all deployments should have memory limits, and it can really be anything. My only ask for you is to never deprive your Kubernetes resources from testing. Remember, your Kubernetes manifests are also part of your source code. Step number 2, integrate the policies in your organization. After you define the policies, you know what are the rules and you know exactly what you want to enforce. This is a time to think about where you would want to enforce it. Because where you will decide that you want to enforce it along the pipeline might affect your entire organization. If you decide to integrate the enforcement in the CI/CD pipeline, for example, and to validate them on every code changes, then it can be very much essential for the developers team in your organization. But on the contrary, if enforcing the policies in the cluster, in the production environment, this would be much more essential for the DevOps engineers in your organization. So really think about it. But let's say that you decided that you want to enforce the policies in the CI pipeline. Then I would highly recommend for you to use ConfTest, which is a tool that builds on top of OPA. And ConfTest basically enables you to write tests on any structured file. It's specially designed to be used with the CI as a local testing library or even as a pre-commit hook. And under the hood, as I said before, it's built on top of OPA, so all the policies that you will write, you will have to write in Rego. And one of the most awesome things in ConfTest, in my opinion, is that ConfTest allows you to push and pull your policies from Docker registry. And to use ConfTest, this is pretty straightforward. First, you need to install it, download ConfTest on your machine. Then you will have to write the policies that you have defined in step number 1, write them into a Rego language. And then all you have to do is to run ConfTest test command with the path of the files that you want to test. Here, for example, you can see a policy that we've written in Rego. And this policy validates that a deployment YAML, the deployment resource, would have app label. And just like that, you use ConfTest, very simple, very straightforward. To use ConfTest in the CI, here, for example, we've used GitHub action. And as you can see here, we pulled ConfTest, we pulled our policy, and we ran ConfTest test with our path. And that's it. That's basically it. But let's say that you want to ship right, and you want to enforce your policies in the production environment. Then I would highly recommend for you to use Gatekeeper, which is also one of OPA's tools. Gatekeeper is policy controller for Kubernetes. It's a customizable admission webhook that enables you enforce your policies. And the way that Gatekeeper works is that it integrates with Kubernetes using the dynamic admission API as a customizable validation admission webhook. As you can see here, so on every request that comes into the cluster, Gatekeeper sends the policies and the resource to OPA, and checks if for any violations on a particular policy. Now, if OPA does find any violations, then Gatekeeper will return the policies error message, and the resource will be rejected. So you won't be able to kubectl apply. To use Gatekeeper, all you have to do is first to install it on your cluster, write the policies that you have defined in step number 1 by adding them as the constraint templates, which will represent the actual policies that you want to enforce. And after you defined and you added the constraint template, you need to add and define the constraint that will actually get invoked when you do kubectl apply. But that's it, pretty much straightforward and easy to understand. Step number 3, control, review, and monitor. What if you have 300 of repositories? Nothing is really static in our world, and you probably would like to be able to dynamically adjust the policies according to your organization need. You would want to monitor all your organization policy checks and maybe get a report for that. Then, if this is the case, I would highly recommend for you to use our very own Datree application. Datree is a CLI solution that, just like Conftest, enables you to test policies against YAML files, but the main difference between us and Conftest is that Datree comes with built-in policies for all Kubernetes best practices. In addition, we also provide centralized management for all your policies using the UI application. Things like creating new policies, adjusting your rules for that policies, and lots of other stuff. The way that the CLI works is also very, very simple. The CLI pretty much runs automatic checks on every resource that exists in a given path, and for every violation that it finds, it will show you a full output with guidelines to how to solve it. To use Datree, all you have to do is to install it on your machine and execute it on a given path with your path of resources, using the Datree test command, the same like conftest test. And last but not least, it's an open source, it's free, and my teammates and I wrote the code, so I really encourage you to review the code, submit a pull request, and help us make it the best solution for your production. To sum up, I really want you to remember that sooner or later your Kubernetes will become your production temple, and you will spend a lot of time and resources on embracing it and adapting it. The way that I see it is that it's not only about adapting Kubernetes. It's a culture. It's about adapting DevOps into your organization, and this is not something that happens overnight. It's a process. It takes time, and you should really think about how you want to manage it and how you want to really manage it, especially in scale terms. And I hope that this will inspire you to start thinking about what are your policies in your organization, how you want to enforce them, and what are the rules that you want to build in your organization, so you will feel much more confident to ship your code to production on every code change. Thank you very much.